There we go. Okay, so yes, if you're joining in on recording, apologies, I forgot to record the first bit, but thank you, Meg, for reminding us. And yeah, so these are our 4 steps. Let's take it to actually using them. So there we go. You're probably grateful that you can't hear the music now. So what is coding? That's our first question. And it's this mix of data and logic. So let's look at what is data and what is logic, because we work with both of these all the time together. So, okay, data might be the price of flour. Logic will be working how much you'll be spending on flour during lockdown. Yes, if it's available, of course. Data, a list of ingredients. Logic, knowing how to put these ingredients together, so a recipe. Data, the name and price per slice of a tasty pie. Logic would be eating that pie with a fork and not a knife. You know, and this is a good example of, there's lots of different ways to solve the same problem. Your logic might work, but it might not be the most sensible logic. Like, do you really want to be putting a knife in your mouth? No. Is it going to achieve you the eating of pie? Yes, but it could be dangerous. So let's just go through these data types here and put these into actual, like, we'll use Ruby today because I think we've got a mix of people from across the course. So the price of flour, what data type might you represent that with?
Float?
Yeah, absolutely. So a number type and specifically a float, probably, unless you're in like some super hipster cafe where everything's just round numbers, which is possible. All right, list of ingredients. How could we do that?
An array?
Yeah, I agree. If anyone was at that Python versus Ruby talk I did, was that only last week? A list is literally what they call their array type, data type. Okay, name and price of a slice.
A hash?
Yeah, a hash in Ruby, object in JavaScript. Yeah, so it's this idea of there's 2 pieces of data, they're related, so perhaps a key value pair is correct here. I'd say probably that the price is pretty set. We're not really going to be able to use a different data type. The list of ingredients, name and price of pie, maybe we could be flexible around that. But I think those are the ones that make sense, so nice job. All right, so we need both, right? So if we're going to make a program, we need both data and we need logic, and one without the other isn't going to be all that good. Today, we are going to mostly be working, as I said, with logic, but we do want to know what data we're working with. So what is a pie? In English, a pie might look like this on a menu. And a menu is definitely going to come up today because a menu is another type of collection that we're going to have to work with. So this pie has got a name, Marshmallow Mermaid Pie. It's got a price per slice and it's got a price per whole pie. I don't think we'll use that today, but this is what it might look like on the menu. Okay, how might we represent this in code? I don't mind what language you say. What data type could we represent this with? Oh my gosh, I just saw Pikachu on the screen. Yes. If I asked you to store this data, how would you do that?
A hash?
Yeah, I agree. These are pretty definitely key value pairs. So name, Marshmallow Mermaid, slice, 450, whole, 15. Note, if anyone who's not got JavaScript yet, note how similar this looks to a Ruby hash. In JavaScript, we call this an object, and actually you could literally copy paste this into Ruby and it would work. Yay. So, okay, how do we order and eat some pie? And I want us to, this is quite I guess an old exercise I remember doing at school. My teachers would say, okay, imagine you were explaining this to an alien. An alien's just landed on the earth and they're like, yo, that looks good. How do I get some of that? how would we declare that? So we have to be very specific. In that context, we have to be very specific. This alien has no idea what's going on. So we're like, first, you have to say what you want. You can't just like go take it. You need to be nice. You need to say what you need in life. Then you have to wait. You have to be patient. Then you have to eat it all up. Then you have to pay. And then you roll home because you're probably struggling to walk after all that pie. It's possible that on this planet that this alien came from, they have something similar. So they may come in with some previous context. So context is really a key word of today. What context are we working in? Are we working in a context where I'm coming from a place where I know absolutely nothing and I need to be told everything? Am I coming from a context where I know how to eat pie with a fork and not a knife? Or do we need to add that in as well? So as you can see, my description to this alien is actually assuming a lot of knowledge if we were to break it down, but not all the knowledge. Like if I was like, hey, Erin, can you go order me some pie? Actually, no, you can eat my pie as well. Like Erin knows what to do. She doesn't need these just explicit instructions. But that's not the same for everyone. Some people might need more, might need less. And that's exactly the same with our code. So when we start from scratch, we might think that we're starting with nothing, but actually when we're using a language sort of like Ruby, actually like any of our language, if you're not working in binary code, you're probably working with something which has got some predefined methods where you can use them. So Ruby already knows, for example, how to add numbers together. It's got that addition sign. It's the same as we use in just written down in maths, right? It already knows that, so we're not having to teach it. That's something we kind of take for granted, but if we were working just in binary, maybe we would need to explain that a little more explicitly. Ruby knows how to take an array and reverse it with dot reverse. That's really cool. Like that's complex, right? If you were to explain to your code, if your code didn't have a dot reverse method, you'd have to explain quite a lot of steps there. You'd be like, take the last thing off the end, remove it, put it on the beginning. All your indices go up one, because remember in arrays are indexed. So if I add something to the beginning of that, then all my other indexes have to increase as well. This is all happening like, it's all in the source code. It's awesome. So we don't have to worry about that. Not in Ruby anyway. And then again, in different languages, you're going to have different prior context. And it's the same with writing your own code. Maybe you're starting with the base of Ruby, but you're bringing in some libraries that's going to help bring in some extra prior knowledge. You might be writing stuff as you go along and you can reuse it. Context, big deal. All right, so yes, how granular we need to get depends on who we're talking to. All right, so let's just make it work first. So we don't really care how efficient or attractive it is. We're just going to make it work. And even as we put this down, hopefully you'll be like, well, actually, do you necessarily already know how to do that? And no, you can get really, really, really granular on absolutely everything. Did anyone ever have to do that exercise? I just remember this really strongly from school, where we were in pairs and we had to pretend that we didn't know how to walk and we had to instruct the other person how to walk, and it's impossible.
What?
Our bodies,
No.
I mean, like you cannot do that, because there's autonomous movements that our muscles make. Our muscles like contract, and yeah, it's crazy. I must have gone to a really mean school. But yeah,
we need to teach somebody how to make a sandwich.
Yeah, see that would be more approachable, right? But they were like, no, yeah. Walk.
Walking seems insane.
But I mean, how granular do you get with a sandwich?
Do you
grow your own wheat?
We did a code talk over pseudocode about how to peel an orange.
Nice, that's awesome.
We found out there's 3 different ways people peel an orange. Like everybody's like, wait, you peel it like that? Like
you're crazy.
Yeah.
Just put the whole thing in.
You get
Yeah, and then if you're American, is it a peanut butter and jelly sandwich, or is it, you know, bananas and bacon and peanut? It was like that was where the granular part came in, was like what kind of sandwich, like, and then like is it lettuce and tomato with cheese? You know, like you had to like break it down, and like there was like too many sandwich combinations to teach somebody how to make a sandwich, in my opinion.
Hold on, did you say bananas and bacon?
Yes. Have you not heard of Elvis Presley's sandwich?
No.
peanut
Peanut
butter,
butter, bananas, and bacon. He
I
was
mean,
known,
Okay.
he was like famous for this weird combination of a sandwich.
he did
And he
die of a heart attack, so
fried it in a pan.
I don't know how ready I am for that kind of excitement in my life, to be honest.
Peanut butter.
Ew. Okay, cool. I can get down with like the bacon and the peanut butter, but not the bananas on top of that. Maybe that's a strange combination to be okay with. Okay, so as you've experienced, we can get real granular on this, and people can get you can disagree. But let's make it work on a very basic level. So, there we go. All right, I've just been served some marshmallow mermaid pie. I've been given 3 slices of it, winning. I'll pick up the first slice and I'll eat it. Pick up the second slice and I'll eat it. Pick up the third slice and I'll eat it. And it's $4.75 a slice. That's $14.25 for 3. So some quick maths. And I shall take out my money and I shall pay $14.25 at the till. And I've done it, right? It works. Let's go and make it work in code first. And I've already got this pre-written out because I want to go through all 3 pi, and then we'll take another scenario for us to code together. So I reckon Ruby looking at the room, yeah? I think we've got some non-JavaScripters. All right, cool. So here's what I've
Ruby.
Sorry, Meg?
I said I would love to do Ruby.
Yay!
I've been in JavaScript land for a while.
Yeah, well, I mean, I love JavaScript, but I also love Ruby. I love Ruby the more I learn about Python. I really like Python too, but the more I learn both, the more I appreciate the other as well. It's very interesting. Okay, so this is what I've got here. Let's make sure nothing else comes in. No. Let's run it and see what happens. It works. Beautiful. So my intention as we go through these different steps is to always have the same output, apart from the title. The code's gonna look sometimes pretty different, but it's always gonna have the same output. So this works. What are your thoughts on this? My solution here.
It's not dry.
Okay, and what do we mean by that?
That you're doing puts, eating slice 3 times when you could do it once and loop it. Because, like, what if you had a whole pie and that would be 8 slices?
Right? That would be ridiculous. I love that you said dry. Do you remember what dry stands for?
Don't repeat yourself.
Exactly. And that's literally what I'm doing here. I mean, they're not exactly the same, right? But they're very, very similar. And that's instantaneously like alarm bells. What's going on? Is there a way we could make this a bit easier, a bit more efficient? So it works, but we would love to improve this. So let's see what our next step is, making it easy. And yeah, well, let's see what we've got first. Okay, so we start off exactly the same. I've been served some pie. I've got 3 slices. I'll eat every slice. Yes, that's much better than saying I'll eat slice 1, slice 2, slice 3. It's $4.75 a slice, so this part's the same. I'll take out my money and I'll pay $14.25 at the till. Great. So this is starting to look a bit more normal. Most intelligent living beings could probably understand what eat them all means. We'll we're going to stay very specific in our actual code, but we can point out that we're doing the same thing over and over again. So let's see our resolution on this. So Meg pointed out that this wasn't very dry. What technique might we use to dry this up a little bit?
I was thinking, go ahead.
Go ahead.
I was thinking that you could pass in as arguments to the method, the price and the number of slices, and then
okay, so that's getting real fancy. That's allowing you to choose how many slices you have. Now I've been given 3 slices. This is a 3-slice pie shop.
You could just do a 3 times do loop. If you always know.
Ooh, yeah, I like that. A 3 times do loop. Yeah, that sounds really good. Let's have a look. I've gone for a slightly different one here, but we could refactor to do that times. Yeah, cool. So, well, first of all, let's run it and make sure that it does give the same output. All right, pie please, eating slice. Oh gosh, that doesn't work. Why doesn't that work? Do you know what? Let's take Ron's suggestion. Why doesn't that work? Oh, you know what? It's because I forgot my interpolation. Da, da, da.
Yeah.
Eating slice $1. No. Okay, we're getting closer, guys.
JavaScript seeping in there.
Yeah, totally. I think honestly my language switching is, I think it's getting worse, but that's okay. Like, we follow errors. All right, cool. So this should be, oh, do you know what? I think I meant that $sign to go down here actually, right? Because this should have been, we want that $sign in front of here. I did choose $signs because we don't really have pie shops in the UK. It's really sad. Well, we have pie shops, but it's not the same. It's like,
yeah, I want to eat those pies. I don't want to eat your pies.
I mean, it's just a different experience, isn't it? Certainly, you wouldn't get something called a marshmallow mermaid pie in a London pie shop. I'll tell you that.
Yes, meat pies.
Oh.
Exactly, yeah. Meat pies and things like that. All right, so our output here is exactly the same. Yeah, but we've taken that very repetitive piece and we've used what technique here? Like an overall technique.
For loop?
Yeah, and I mean, we could have also done that times. So I'd say it's just, we've used a loop of some kind. We could use a loop, an iteration, something like that. And that's worked really well for us here. Cool. I think my next example does use times actually. This is fine. I'm explicitly saying I want 3 slices. It's not the most beautiful thing in the world, but it is a bit easier. I'm not, would you call this dry, Meg?
Yeah.
Yeah, so would I. There's not really anything here that's repetitive. There's definitely improvements we can make, but it's certainly not repeating myself in any places. So we're getting there.
The pretty thing.
You're excited to see the pretty thing?
No, I have a question.
Oh, well, that's exactly where we're going next. So go for it.
So making it pretty is like usually talking about the code that we write, not necessarily what comes out, right?
Yes.
Like what we put. Okay. All right.
Yeah,
so I had a question about the pretty of the puts. So I guess that's not really the pretty part.
Are you making fun of my formatting? Because like
no, I mean, is it pretty to have it say eating slice 1, eating slice 2, like?
It's ugly.
Right.
Yes.
So
that was just my question. Like,
yeah.
And I realize it's not on topic because it's not about the code we wrote. It's about what comes out. So
it's about what comes out. And if we think about it, even if we are, this is what we're printing out over here is what's actually happening. And on the left is actually the more descriptive part of it. So if I said to my friend, like, oh, I went to this great pie shop yesterday, I had 3 slices of marshmallow mermaid, I ate them all. What actually happened was still these steps. It's not like any of these steps went away. So this is more, we can imagine it like a ticker tape of things actually happening in that way.
I think I was thinking about what Ron said a little bit about, like, if you gave it the arguments and it could be used for more than just our 3 pieces of mermaid pie.
Exactly. Yeah, exactly. So this is fine. It works.
Yeah.
But like, you know, it's not very clever. There's way too many restrictions. What if I want pumpkin pie? What if I want 5 slices instead of 3? And this is now starting to get closer to how we'd explain the process in English. So let's have a look at this. So I can choose what pie and how many slices I get. Thank you very much. And I'll eat every single slice that I ordered, only what I ordered, not what's available. And this pie has a price per slice, might be different for each pie. What is that times by the number I've had? That's how we usually work out the price of something, plus tax if you're in the US. And then I'll take out my money and we'll pay that much at the till. I've not allowed for tax in my demonstration, by the way. Maybe we can add that later. So yeah, this is getting much closer to how we'd explain this process in English. I went to this pie shop, they had this great selection. I chose how many slices I want, I ate it all. And then actually this pie was really cheap. So that meant I could have 5 slices. So I paid that. It's getting much closer. What are we gonna need in order to do this? What that we don't have at the moment?
A set of the pie and the prices?
Yeah, absolutely. So in English, we'd call that a menu, right?
Yeah.
So we're going to need a menu of some kind. And we're going to need a smarter order taker. So at the moment, we've just been like, pie, and I get served 3 slices of marshmallow mermaid. Like, it's not a bad life. But now we need to be able to have a little bit more conversation with our server. So let's have a look at what we've got here. So let's have a look at my menu. So we've got a hash here, or an object in JavaScript, and it's got 2 items on the menu. Each item has got like a code name, so we can kind of imagine this as what they might put into the till. You know, if you've ever worked a till, usually it doesn't say the whole name of something, it's some sort of code. So we can imagine this as the code, the till code, and then we've got the actual data held by that. So we've got the name of the item, its actual name, we've got the price, I'm going for slice there, and we've got whole. We're not going to use whole today. I mean, you could do some like cool logic where we add that in, but today, well, for now, we're not going to. So here's what I came up with for this. And let's see if it works. So what I'm expecting is exactly the same output, but for pumpkin pie and for 5 slices instead of 3. So let's run this, see if it works. Oh, hold on. Let's space it nicely.
Make it pretty.
Make it clever. There we go. All right, cool. Oh, it's a 3 as well. All right, so this has totally not worked. Why has it not worked?
It didn't take in the argument of the number of slices.
Yeah, so I mean, it's taken it in, right? Because it says I'll have 5 slices.
Right. But for the pie slice eating part.
Yeah, so this hasn't really worked because I've explicitly kept this here. So how can I make this dynamic? And there's definitely more than one way to do this. I liked where Ron was going earlier, actually. Might be something you can see at times, yeah. Okay, cool. So we wanted to use times. So times works like this. So 3.times do, and then it's gonna do what you want it to do 3 times. Couple of issues here. How are we gonna make this part dynamic? Where do we have access to that number that we need?
Oh, we can just put number of slices.
Yeah, absolutely. So we can just replace that integer with a variable that we have is also an integer. So number of slices. Where are we going to define pie slice? Because previously we were defining pie slice in that for loop definition. So does anyone happen to know how this works?
Couldn't we just use number of slices?
But number of slices is always what?
Oh, a static number, not an index.
So well, let's see if it's doing it 5 times now.
We can.
Okay, cool. It's definitely doing it 5 times, but we haven't got this number isn't increasing. Yeah, sorry, I think I spoke over someone just now.
I said, could we do a counter?
We could do a counter. Yeah, absolutely. I want to just look at the documentation for times, because this is a feature of times.
Ooh, is there something in there that makes it easy?
Yeah, so this is pretty awesome. Let's go to Ruby Docs. Ruby Doc. Let's go times. And we'll go to the Sunday Times.
Why the heck does that come up first? Like, why? It's so.
Oh, it's like, I think it's sponsored ads.
Yeah, but
I think that's how they make money. Maybe. I'm not mad about it. Everyone's got to do that. Cool. So we don't often use times, like when I say we, I mean, like, I think in the curriculum, I don't think we use times like this. But what's this is tiny.
Block.
Yeah, exactly. Yes. What did you just say, Meg? It takes a
block.
Yeah, that's cool. Right?
I did not remember that.
I don't think it's even in the curriculum, as far as I'm aware. I don't think so. But yeah, so that's pretty cool. So it takes a block, and we get a block variable, which is just the index that it's currently on, and we've got access to that in there, which is great. So let's see if we can use that. So they use their curly braces for their block. I'm going to use do and end because I've already got it there. So to get my block variable, let's do this. And I called it pie slice before, so for the sake of continuity, I'm going to do it again. And then we can return this back to pie slice. And let's see.
If that's the index, shouldn't we add 1 to it?
Yeah, so exactly. Choose one step ahead. Yeah, absolutely. So now we've got this issue that it's indexed, so it's starting at 0. So we want to plus 1 to it. I don't know. I wonder if with it, I've never tried this before, so let's just try it and see. If this works, it's messy anyway. But, no, okay. Just oh, hold on. Oh my gosh, it didn't error out, which means probably if I do this. Cool. So, I mean, it works, but it's weird. It looks weird, right? So dot with index is a method that I'm extremely passionate about. You can chain with index onto any iterator method in Ruby, and it'll give you an additional block variable, which is the index you're currently on, and then you can set it a starting point.
Okay, so doing that, what is pie slice then?
Well, it's the index but without the addition. So with using with index with times doesn't feel very helpful for me.
It's kind of like doubling out the index.
Yeah, okay. I'm not really loving that. But I mean, logically it works, working on that logic. But I think in this case, and I wouldn't, if we were using .each and we were interested in the value of each item in an array that we were iterating over, I would definitely advocate for with index. In this situation, I think generating an index twice is a bit weird.
Or I was gonna say, can you put that parentheses 1 after the times?
Let's try it.
Since it like does it.
No. No. The more you do this stuff, the more you'll get a feel of what's probably going to work. Like that with index. Just had a feeling it was going to work, but it wasn't good, right? Just because something works doesn't mean it's good. In this situation, and yeah, it didn't make any sense to me that times would receive an argument. But yeah, it's, as you see, like nothing happened. There's no issues. Just trying it out, we got an error. So try stuff out. Why not? So instead, let's just do it this manual way and +1 to it.
That's so neat. I'm glad we did Ruby. Learned something new.
Yeah. There's always something you need to learn in Ruby. There's always something you need to learn everywhere.
Yeah.
Yeah, it's pretty awesome. So this is totally working now. Beautiful. And let's give it a go. If I wanted to have Marshmallow Mermaid instead, in fact, let's keep that as pumpkin, just for the lols. And let's make this Marshmallow Mermaid, and I just want one slice, one diet. Cool. So make it clever. 5 slices of pumpkin pie, 1 slice. Oh, I mean, it would be nice to have some formatting conditionals here. 1 slice of that, please. 1 slice, and it's $4.75. Cool. So that's absolutely working. So we're dry, we're clever-ish. What is the next step? And then in the actual song, the next step is craft into pieces. So what would you define this as in programming? If anyone's wondering, I am drinking wine.
Single responsibility principle.
Yes. Oh yeah, absolutely. Do you know what? I don't even have that written anywhere in my presentation, which is sad. I'm really happy you brought that up.
Written on a Post-it note on my computer.
As it should be. So do you want to give us a brief overview of what that means?
It means that each piece of code that you write is supposed to be responsible for one thing only. You don't want it to be doing more than one thing, because that's basically abstracting it down to its most basic job.
Yeah,
that's what
absolutely. So
because
it's basically
separation of concerns, which is my another
buzzword. Yeah. So yeah, absolutely. Single responsibility principle, separation of concerns. These are phrases that you'll certainly hear a lot. And that's essentially what we mean. It's taking a whole story and separating it up into the distinct parts. So in our example here, I think there are 3 distinct parts here. What are the distinct parts that we have?
Could you go back to your code?
I did not.
I have it here.
So what are the steps of eating pie in this context that we've been given, that we've been using so far? Yeah, go for it.
Order the pie.
Order the pie. Yes.
Eat the pie.
Eat the pie.
Pay for the pie.
Can you see my notes?
No.
So yeah, absolutely. It makes sense, right? How do we go to a shop and order a pie? We order it, we eat it, we pay. Done. End of story. There's obviously lots of steps, like maybe getting to the place, getting home afterwards, and we could add on. But these are the 3 mini stories that we've been working with today. And if anyone's into writing, we can kind of think of this as like an exposition middle end kind of thing. But we don't have to take it there. So what does this look like in code? So what
would you make my brain is fuzzy. Would you make methods for each part?
Yeah. Absolutely. So that's exactly what we're going to do today. And that's a really clear way of abstracting things out. So we're going to take these individual pieces and we're going to rip them out gently and make them into little reusable blocks of code.
Right.
And then once we've got these reusable parts, we can put them together in different ways. So, I mean, at the moment, most of us, for example, aren't going out to a pie shop. We're getting it delivered, all right? so we need to order and pay and then eat after a wait. So the order needs to be switched around. So what we've got at the moment in our 3 perfectly valid examples isn't actually suitable for life at the moment, because we can't usually eat before we pay right now. I like that because it's a very tangible example of why we need to be able to extract these little pieces out and Lego block them together in new designs. So yeah, let's go and see this in its full form. So it's a bit more code visually, right? But having a bit more code to start off with is probably going to save us a lot of code later. If we had to rewrite like pie during lockdown, we'd have to rewrite all of this, but just slightly changing the order of putting the payment above the eating. Whereas once we've actually made the separate pieces, we can make our own sort of master method to put them all together. So let's first of all make all our little helpers. And let's start with order. All right, cool. So my order method, it takes in a selection and slices. It says I'll have the number of slices of the name of the selection. The selection is still going to come off that same menu. I think that's it for ordering. Does anything else need to happen? Not really. Eating it. So it's literally just this guy here. There we go. He's ready to go. And payment, probably the longest one, really. So we're taking that selection and note that, so order and pay both take in selection. Why have I not passed in selection to eat as well?
Because it doesn't matter what type of pie.
Yeah, exactly.
How many slices?
Exactly. I'm going to eat it the same way. I'm sure people have got edge cases for that. Like, well, if it's a very moist pie, you'll need to use a spoon. But yeah, generally speaking, we don't really care which pie we've got. We're just eating it. We're eating all the slices. So that's definitely another part of this, deciding what data is needed. So we're avoiding the unnecessary exchange of data to places it really doesn't need to be. Which is really nice and efficient, and also there's an element of security there as well. Maybe not in this app that we're making today, but perhaps on if we're using user information, you don't want to be passing it around where it doesn't really need to be. Okay, cool. So I've got all these helpers by themselves. They're not particularly useful. So I've made this master method here, which calls them all, and it looks really simple. So it takes in, again, the pie selection number slices exactly the same as my previous ones, but then it's going to do each of these individually. So let's take pie, and I want 7 slices of pumpkin pie. I'm just going to get rid of this guy first. And let's run. Okay, oh, I left out my beautiful legibility formatting. For craft it. Okay. Cool. Let's get rid of this. Let's run it again. Great. So output exactly the same, except that it's $7 slices of pumpkin pie. No. Okay, no, okay, but now it's fine. So yeah, so again, output exactly the same, because no matter how we describe it, the actual event is still the same. I go to the shop, I order my pie, I eat my pie, and I pay. That doesn't change, and it shouldn't change. But just how we're expressing it changes. Okay, so let's make another method that's more suitable right now. So pie in lockdown. What do I need here?
Delivery method.
Oh, so using the helpers that we already have. So what would I have to do first?
Order.
Yeah, I want to order, and let's still take in selection and slices for pie and lockdown. Order takes in both. And
pay and then eat.
Yeah, absolutely. Pay and you know, maybe we don't want to eat right away. We can save that for later. We can do it another time. So yeah, let's just take pie and lockdown. Let's get marshmallow 2. And let's just call it take out.
Pie on demand.
Pie on demand. Amazing. Awesome. So craft into pieces. Yeah. So all these are the same. And then for this one, for takeout, we've got our, okay, I'll have 2 slices of marshmallow mermaid. It's going to cost $9.50. Here's $9.50. That's it. And then we could totally add additional helper methods to handle the delivery. But then later, if I wanted to eat my pie another time, then I don't have to even have a master method. I can just go, okay, I'm eating, and I'm eating 5 slices. So there we go. So I didn't call this within that lockdown method. I was able to wait, and when I was ready, I ate. Yeah, maybe I don't want to eat all my slices. I just want to eat one of them at a time. So yeah, I think that's a nice example of how we can take one big story and extract it out and rework it together. It's very like Lego. Yeah. So what is the name of this whole process in code?
Abstraction.
Yeah, absolutely. So abstraction. So I found a very dry definition of abstraction: the act of removing elements of specificity to emphasize commonality. Okay. So in real life, what does that actually mean? Well, depending on the scenario, we might describe the same object or the same action or the same story in different ways. And then slightly more, well, I guess another aspect of it that we did touch on, we're only using the important details. So when we were eating, we didn't need to know what pie we were eating. We only needed to know the number of slices. We didn't need all that information. So we just gave the important details for the task at hand, as it says here.
Hey, Beth, can you go back to the other definition?
Yes.
I just want to take a screenshot of it.
Sure.
Because I
can share, I think I can share slides afterwards as well.
Okay, thanks.
All right, cool. So, okay, so another way to describe abstraction would be the really focusing on the differences, I suppose, between something concrete and something abstract. So I did find an example I didn't really like, so I didn't use it, but I've used it to inspire some other examples. So concrete would be my Jaffa cake recipe. Abstract would be Jaffa cake recipes. You know, my Jaffa cake recipe involves like 4 tablespoons of whiskey marmalade. But Jaffa cake recipes in general need some sort of orange jelly disc. That's it. I can see Erin's lying. She's like, yeah, whiskey marmalade. okay, concrete. So this is one that we have actually on the tube here. Concrete would be like a topographical map of London. On the Piccadilly line here, which is the blue line, nobody cares. We've got a map of sorts, but it's not accurate in any way, shape, or form. But it's just a line that metro line takes, and then some illustrations of places along the way. So it's an abstraction of reality. But honestly, it does a really pretty good job. You know, that's all the information that's needed. If I've just got off a plane at Heathrow and I get on the tube and I am keen to go to Covent Garden, I don't actually need to know what's going on between here and Covent Garden and everything else. I just need a picture of Covent Garden next to the right stop to get off at. And anything else would just been a hassle, you know, go to Smith's, buy a map if you need more. And then closer to the one I found, in India, apparently the largest statue in the world, it's called the Statue of Unity. So that's potentially even literally, I'm not sure, it might literally be a concrete item, but the abstraction there is this concept of unity and togetherness. The one I saw online was using the Statue of Liberty as the concrete version, and this like ideology of like liberty and freedom as the abstraction. But I preferred the Statue of Unity. I thought that was nice. All right, so yeah, I mean, any others coming to mind? Concrete versus abstract. Meg's face.
I'm really not good at this.
I didn't find it easy to come up with these examples.
Yeah, they have some similar ones, you know, topical graphical map of like Manhattan and then the subway. I mean, it would be the same.
Oh yeah, that's a good one actually. Every single underground map in the world is an abstraction of what's actually happening.
Yeah.
Yeah, it's not easy, I don't think.
You could say bus routes.
Yeah.
As well would be an abstraction, because like the picture is just a little squiggly line. It doesn't really have reality with it.
Yeah.
Can you explain that map one again?
Yeah, let's see if we can just find it. So here's a literal map of the Piccadilly line, but here's the abstraction. This isn't what I was intending to give you, but it just came up. Let me see, Piccadilly line.
Okay, so it's like
here it is. All right, so it's Pinterest. You can't.
The abstractions like the tourist guide, like, oh look, this is, and it makes it look all nice, and here's this stop and that one.
So this is it's an updated one to the original, but this is the exact one I was talking about. So this particular metro line, for example, starts about 40 minutes on from Hammersmith down here, but that's the airport. Most people, unless you live along that stretch, are not going to get off before Hammersmith. So they didn't add this to this abstraction map because it wasn't considered an important detail. There's loads of stops missing along here. Actually, is that true? That's not true. All the stops are here for this stretch, but they've only taken the stretch that is they're considered most important for the majority of people who are going to be on that line, getting off at the airport. And okay, so I know now roughly where to get off for each of these items. You might be like, oh, Harrods, yeah, Knightsbridge, okay. This is Buckingham Palace. It's not that colour in real life, but I can see that I get off at Green Park for this, and I think that's it's a pretty abstraction. There's maps is a good one. There's lots of map abstractions.
But like in the actual topographical map, it's like all working its way differently. It's not these smooth little.
Oh, it's completely different. Yeah. Okay. Piccadilly line.
Concrete.
So this is the shape of it, but I would be so lost. If you gave me this map, I would be like, I have no idea what's happening. I've never seen the Piccadilly line demonstrated like this in my life, but that is actually the shape of it.
Yeah, you see, like, looking at stuff like that makes more sense to me. Because I'm like, yeah, okay. Well, as you can hear, I live next to a train, so that's why.
Well, so you must get used to, like, so for a long time, the straight line, when they show you, like for New York or for the tube, it's just a straight line, but the lines don't run in a straight line. Like, some places they do, there's a bit of straight, but that always was like, I was like, nothing runs in a line. Why are we showing it in a line?
Right. Do you know what? This one's actually pretty close to real life. Let's go.
Yeah.
I wonder if circle line, because this ain't a circle. Well, I'll make this my last search. So the circle line is literally represented as it's not even represented as a circle, but a little extra. Wow. That's not true either. Wow. Okay, this is so cool. So these are all just none of these are true, but they're all abstractions of the London Tube. How beautiful is that? Oh, I love it. Okay. Anyway, so yes, abstraction. That's a nice way that I like to think about it. But do keep an eye out for things that you notice that are like that. Okay, so what we're going to do now is we are going to take a little break, just a few minutes. And whilst we are doing that, I want us to be thinking of some things that we could create that are, not the same, but a similar idea. So we take a story and we're going to go through each stage of this little story. Some ideas that I thought, like posting to social media platforms, like going to like Facebook, Twitter, LinkedIn, a calculator. I just like animals, so I just put animal shelter. I'm not quite sure what that would look like. But yeah, I'm going to leave it up to you guys to have a think of something, and we're going to start very concrete, and we'll get as abstract as time allows us. Sound okay?
You go to one of those cat houses, Beth.
Cat houses?
Yeah, you go visit, you get to pet cats, but you don't have to take them home.
Oh, like a cat cafe.
Mm-hmm. That instead of your animal shelter, since like then there's like the whole like adopting or not adopting.
That's like
so
gonna have an aneurysm.
Okay. Well, have a little brainstorm on that whilst you guys take a break. And please stand up, have a stretch, and I'll see you back here. It is 32 now. Let's aim for 35. I'll wait. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Can we have 14. Like a 5-minute break?
Yeah.
Okay.
So let's go to 37.
Okay.
37. I've got 14 at the moment. I'll start with 12. All right. I'm going to wait till the minute of 37 has passed.
What kind of wine were you drinking, Beth?
This is a rosé. It's interestingly enough, so we order like a selection of different ones every so often, and this one is it says it's been bottled for Jolie Pitt. So I was like, Angelina Jolie and Brad Pitt make wine now? So I just thought that was really surreal. It's very light, it's very smooth, it's even easy. It's okay.
All right. It's a little too early here.
Yeah, no, absolutely. I don't know. I think you can get away with like a mimosa at brunch, right?
Yeah.
Yeah. maybe not a wine. All right, let's get going. So, yeah, any thoughts? Any thoughts about what we could create? I'm not gonna lie, I like the cat cafe idea. We're gonna stick in Ruby. Yeah, does anyone come up with anything? Just all busy getting your mimosas. That's okay too. Yeah.
I like the cat cafe also.
Yeah. All right, cool. Let's do cat cafe. Let's focus on the cats as well as the cafe, because cafe is quite similar to pie. All right, let's create this. So let's tell a story, now just in English at first, of what happens when we go to a cat cafe.
I didn't mean to start something.
Oh, it started. So what's the first step? If I was telling a story to someone about, or telling someone how I go enjoy myself at a cat cafe, what would be step one?
Well, we didn't enter the building for the pie shop, so I'm guessing the same sort of parameters are kind of
It's
there.
a different story. We might be working in a different context, and we can start as granular as we want, really, you know.
Yeah. You would need to, I guess, interact with somebody to know, like, to tell them what you're doing there.
Okay. Well, I guess proclaim presence.
Yeah, or proclaim, intention. Like if you're going to be there like 5 hours, I guess.
Okay. Yeah. Proclaim presence and intention. So okay. So we might have to define exactly what those are later. Okay.
And then you have your interaction with said cats.
Interact with cats.
And then there'd probably be a paying part.
Paying.
And then leaving. Paying and leaving.
So this also, you can order food and drink, right?
Pardon?
You can order food and drink.
Most of them have food and drink. Some of them are just a place to hang out with cats, but most of them have food or drink.
Can you order food for the cats, or is it just there for you to use? Are you allowed to feed the cats?
I think it depends on the place. So if you wanted that to be as part of our story, we could have that be part of our story.
So let's say you also have to order food for cats. And it makes, I guess if you were going to allow people to feed the cats, you would have to limit that in some way. At least, maybe even if you didn't pay, you'd have to say, hey, may I have some food? And they might say, yes, here's some food. Please only feed
this
Fluffy.
cat.
Yeah, because this one cannot be fed.
This one's a little carb happy.
exactly. All right, cool. So let's just put down some rough ideas for like a do it all method that, you know, it's a bit, it can be messy as anything, but we're just defining what our output is going to be. So we're not starting with we're not thinking about any abstraction at all. We're just thinking about what is our output going to be. And when I say output, I do literally mean here our consoles, yeah, so our puts. But in terms of reality, I'd be saying, okay, what are the steps? And the steps don't change, just how we describe them changes. So visit cat cafe. Okay. And we'll start without any variables, so they can only intention to stay for, let's say, 2 hours. Order food and drink for humans. We'll order 2 teas and 2 cupcakes. Order food for cats. 1 bag of food. 1 small bag of food. Interact with cats.
You forgot a step.
Sorry?
You forgot the adopt step.
Yeah, fair enough. Adopt a cat. Adopt a cat. Okay, so in our
Cat lady starter kit.
Sorry?
Cat lady starter kit.
Okay, adopt a cat. Pick up your starter kit. I can't help feeling this is a little unethical, but here we are. All right, so let's say puts enter the cat cafe. And this is very much just sort of pretty much writing down what we've got. So then we are puts I am here. So I think I'm assuming a party of 2 actually, because I'm ordered 2 teas and cupcakes. There are 2 of us. We wish to stay for 2 hours. All right. Order food, drink for humans. 2 teas. Oh, hello. 2 teas and 2 cupcakes, please. Sounds like a great time already. May we feed the cats? So we might have to have some conditional statements in here, please. 1 small bag of cat food, please. I'm literally writing out a conversation here. And I think writing out a conversation is quite a good way of actually figuring out each of these different parts. Oh no, I've just seen I've got chat messages. Okay, great. Oh, cat lady starter kit. Yes. Now it makes a lot more sense. Puts let's see.
Beth, I have a question, because you said that for like feeding the cat, we might have to put a conditional. And whenever I do pseudocode, I normally write the conditional in the pseudocode, like if yes, and then I write like what'll happen. If no, and then I write what'll happen.
So the difference here is we're not writing pseudocode.
Oh, I thought that's what was up above.
Yes. Oh, yeah, sure. So I suppose up above we could put this in. If I order food for cats, I mean, if we
was just wondering. I was like, we don't have to. I was just wondering.
No, you're right. I mean, and we will. There's definitely some elements here. We cannot assume that everyone wants to adopt a cat when they go, and we cannot assume that we can feed the cats. So I think in our user story up here, this isn't quite a user story, but I think it's a good idea to put in these ifs. Even English has if statements. All right, here's $35 for my wallet. Oh, I forgot to interact with that. Yay. Cats. Purr. And let's see. I would love to adopt. What's the name of a cat? Pip. Pip's hooray. Here is your cat ladies starter kit. Pip's leaving cat cafe. So this is one example of an output we might see. So as we go through abstracting it, we're going to have to think about, might that yes ever be a no? And that's going to count as dynamic data. So our first, I mean, if reading through this, what would you say is the first piece of dynamic data that we're probably going to hit?
The amount of time, well, the number of people.
Yeah, so there's 2 already right here. So that's going to be one of the things we have to address. That's quite obvious, I think, that one. But then maybe we feed the cats. Yes, is also going to be a dynamic piece of data, and not an integer. So let's run this. Yes, Pip is Meg's cat, and he's not up for adoption as far as I'm aware. But it's a good name.
I'll never give her up.
Oh, I didn't actually call my method. Cool. So let's aim to, well, let's take like 30 minutes to just abstract this as much as we can in that time. And there's always new places we can take it. You know, we might, I don't think we're going to do it in 30 minutes, but we might get to a place where this could be used for a cafe of any kind of animal, you know, and there's lots of things to think about in there. Actually, that would be quite an easy one to do. So, but we'll leave it for now. It's cats. Okay, so it's working. It works. Let's make it easy. Do we need to make anything easy here? I'm not sure that there's anything repetitive here. But I'm up for debate on that.
If you want another bag of cat food, maybe. Sorry.
Oh yeah, okay. Yeah, okay. So let's maybe in our example, let's go 3 small bags. And then actually maybe for our interaction, let's no, do you know what? Let's 1 small bag, but we'll put petting first cat.
I was kind of thinking,
it's gonna be hard.
Like, you'd probably give the cat a treat instead of a bag of food, and like you give cats treats, like different cats treats.
Yep. I think for the sake of time, let's just pet them and let's just buy 1 small bag. Okay. I think, and the reason I'm doing that is I guess I'm already abstracting and I'm already thinking of units. So yeah, so what units actually do we have here? I'd say entering the cat cafe. I'm interested to know what you guys think. What units can you see?
You have a entering the cafe. You have a
ordering.
Or an ordering human.
Yeah.
Okay, so which part does line 13?
Oh, sorry, not ordering human. The stating our purpose and intention part, like the ordering our time.
Yeah, I'm wondering, do you ever enter a cafe and not state something like this, your intention?
That's a good point.
You don't want to over abstract, right? Otherwise you're just going to have lots of like tiny little things.
Break it up into like the cafe part, like the cafe part, like where you enter and order, and then the kitty part where you interact and like you start with the cat. So like, can we feed them? And then you're petting them, and then it's like now the bill time, and you decide to adopt. Or is that like not abstracting enough?
Well, that's the thing. So it's that could be our first level. And as you're already seeing, this is getting my favorite word in code, philosophical. It is getting a little philosophical here. And I think this would actually be a great place to start. Let's take it down to these 3 layers. And I think the little bit of drying up that we need to do, I think we can do as we do this. So let's make our helper methods of I guess arrive and order. And cat time. Captain. And
for the sake of time, we wouldn't do this, but if we were really writing this out, we would probably give ourselves like a option to add more time, like in our order, right? Like if we were really extracting it out,
maybe why can't we do that now? Like and I think that would be the next step. So let's first of all take what we've got and make it into these helper methods. This is slightly different order to what we did before. Earlier we sort of made it clever and then we crafted it into pieces. This time let's craft it into pieces and then make it clever, just for the sake of variety. So
I just wanted to ask. I wasn't trying to add. I was just curious, like.
Yeah, totally. So well, I think we are going to do that. I think so. Yeah, I think you're right. I totally just copied the wrong thing. So arrive and order is entering in this. May we feed the cat, and all this petting business is going to happen here. Do you think adoption goes in cat time or ending?
If it were me, I think I would make it its own thing, but we're getting really like extra layers.
Especially because adoption may or may not happen. That's going to be a conditional thing, right?
Yeah, that's true.
Like, because not every cat cafe has the option of adopting either.
Right. Okay. And so actually, with the payment bit, we need these 2 and leaving the cat cafe. And I wasn't going to move these, but let's actually do it.
So the payment and the leaving part would have a lot of bits from like every area.
Yeah, exactly. So we'd have to keep track of some stuff along the way. Okay, cool. So let's go. Concrete. And all right, so now I've got these. I need to make some sort of master method to actually call them. So what's that going to look like? So we've got visit cat cafe, and then let's make visit smart cat cafe. Oh, let's visit improving cat cafe. I won't call it smart. So how would I put these together?
You just call each method inside of there?
Yeah, absolutely. So, and I think for now, we've decided that this is the order that we'd like to do them, but it's very possible that that, you know, this could totally be flexible. All right, cool. So for the sake of ease, I'm gonna make a world where I have decided what if I wish to adopt a cat before I go. So what kind of, I'm thinking about how can we make this conditional based on something that I pass in. Let's say I visit the Improving Cat Cafe and I pass in adopt. Or let's just pass in true and receive something of adopt. What would be the quickest way to make sure this only runs if that is true?
Put the condition in the adoption method.
If I am not going to adopt, do I need to even call the adoption method? Let me just change these. So I just realized I've used.
Okay.
So how could I add a condition before, like deciding whether I even actually run that method?
You can put on line 65 if true, or yeah, adoption
True.
True.
So true is always true. What are we checking to see if it's true?
If adoption ready to adopt.
Yeah, exactly. Now, because I've decided to pass it in a Boolean value, I can just actually give it this, and it will know if it's true or false, which is pretty sweet. So let's give this true for now, and let's actually not call visit cat cafe. Oh no, we can. We have space. One second. Now it just looks like we're going crazy. Concrete, improving, stage 2. Let's see exactly what it says. Okay, cool. So the output now exactly the same. Excellent. If I make this false, then the adoption aspect is gone. So great. And the reason I wanted to put that here as opposed to in the adoption method is because, as I said, like even if I don't want to adopt, there's no point even starting this process just to be chucked out of it again. All right, so let's see what can we.
So you said earlier too, we put the condition on the feeding the cats.
Yeah. Oh yeah, absolutely. So I don't have direct access to that here. That is going to be in cat time. Mm-hmm. So now this is a bit more of a complex one, right? So cat time. How can I do this? So let's say cat time, and I'm going to pass it of okay to feed, and let's pass it true again. So now what can I do here?
I think that needs to be abstracted further.
Okay.
Into feed and pet.
Okay, yeah, I like that. So it'd be great if we could do feed cats, pet cats, feed cats only if
okay to feed.
Okay to feed, exactly. Okay, so let's just quickly make those. Feed cats. Oh. Feed cats. And again, we've not even started to feed the cats. We've I mean, we're saying may we feed the cats, but oh, there we go. It's polite. It's still polite to ask, right? If I see a sign saying, oh, you can buy cat food, I'm still going to be like, hey, is it okay if we feed the cats? So that makes a lot of sense. And then pet cats. Okay, cool. So this doesn't look dry, right?
Mm-mm.
This bit. So, and it's not just a case of cat 1, cat 2, cat 3, because cats deserve more than an index. So what could we do here? And let's say maybe I don't get to choose. Perhaps maybe these are just the 3 cats that the cat cafe has. So how could I make this a little bit neater? If I get a 4th cat in the cafe and I have to put like this is old, right? I don't want to have to do this. So what's a better way to store these cats?
I mean, would there be like a passing like a menu but not a menu? I'm trying to come up with a
okay, yeah. So
an array.
Totally. Exactly. Some sort of data collection.
Yeah.
It could, in this case, all I've got is cat names. They don't have additional attributes. So an array could be great for this. And yeah, let's do that. So I think for now we can put it in here. But you could maybe store it elsewhere and pass it down. If you're making this available to lots of different cafes, you would need to do that. But for now we don't have to. So Zelda, Bob, Pip. Okay, and how can I handle this?
Loop.
All right, what kind of loop shall I use?
You could do like a 4 in.
Yeah, so we could go for cat in cats, do, and puts cat. So let's see, we've written a lot of code without typing anything. Cat time, okay to feed.
We didn't put that in the improving cafe method on 71. The okay to feed.
Got it. Thank you.
Yeah, we called feed.
Yes, we have
cat time instead of
on 80. We didn't pass a second argument.
So I don't need a second argument, right? I'm just always saying true.
Oh, okay.
But we also
You're
called
right. That's something we could pass from the top. But this is actually looks like it's looks like I've just forgotten a parenthesis or something. Oh, I don't think I can do the question marks if they're variables. I think I can only do it on methods. Yeah. All right, cool. So, it's not quite right. We need that petting. So let's add that in. Put petting cat. So and each would be equally good here. I think you see each a lot in the curriculum, so I think it's fun to see a for loop sometimes.
What do you think? I actually that was like my first thought is like call an each on that. Like what is that, just like whatever you prefer, or is there one that you think would be better in this case?
In this case, I don't think it really makes a difference.
Okay.
If I wanted to use like with index or something, I can't do that here, as far as I'm aware. So yeah, just things like that. If you need to, I don't think you can get much fancier with a for loop than we're using here. Whether with an each, you can extend it out and do some cool stuff. In this case, no difference.
Gotcha.
All right, cool. So let's see how we're on time. We're doing good. So we've got the output is not quite the same. We haven't added. Oh yeah, sorry, it is. I just took out adoption. All right. So other things we would need. We want to know how many there are. And then now it's a case of just passing in arguments, right? And I think honestly, the best way to really realize this scenario and the pie scenario as well will be where I could actually interact with it. and ask questions. So maybe some sort of command line application would be great here. What would be the next level of abstraction outside of just our methods and passing in different variables? What's the next place we could take this?
Especially the only one that comes to mind is the animals. Like you said, you could use it for other animals, but
yeah.
that seems like a bigger abstraction than you're talking about, I think.
I think that's a good human abstraction, and it'd be great to add that in terms of our techniques that we've got. So in order to dry things up, for example, we've used iteration in order to take out these mini stories and piece them together like Lego. We've used like single responsibility. We've taken these methods and we've made smaller methods and put them back. What will be the next level, especially in terms of like representing real life things in code?
What about making a class?
Yeah, absolutely. So taking us into actual object orientation. So we haven't touched any object orientation here yet. You know, it would be awesome if all of this, like at the moment, I can just call these methods wherever, right? But it'd be great if these items knew that they were part of this bigger picture of being in a cat cafe. Once you've got that, you could maybe make a parent class that is a bigger picture of an animal cafe, bigger picture cafe, bigger picture food place, a public area, and the Ruby's nature of where everything is an object is a really nice vision of this abstraction. So each as you go smaller and smaller in your classes, so bigger and bigger. So you start small and then you get the bigger picture the more you go out and out. So you can also think of that as like just calling .class on everything, our favorite, right? So hello .class. Oh yeah, sorry. I forgot, REPL changed. Let's go into IRB. So hello .class. New. It's a string. Okay, cool. Well, a string, what are you? I'm a class. Whoa, what's a class's class? It's a class. Okay, I've got to the top, so I can know, like, I'm at the top level of my abstraction here. I can get no further. But this is just abstraction as well. Like, they're all classes, but we're getting closer and closer into what we actually need, and sort of weeding through all this extra information and just picking what we need for that specific time period. So, I mean, I'm not sure if I think everyone here is at object orientation now, but let's maybe make a class of cat cafe, pop all of this stuff inside it, and let's just make this visit instead. And okay, cool. So we've now got this class. I've not made any yet. To make a new instance of cat cafe, what do I need to call?
.new.
Yep, .new. Okay, and let's call it caf. And I'm just gonna put my caf. All right, awesome. So this is what it's puts out at the end. It's object notation, so I can tell what class it is, and I can go its object ID. And now I can think of a few ways, all right? So maybe London's got a cat cafe, maybe like New York's got a cat cafe, and maybe in London you can adopt, and in New York you can't. So now what's going on? I'm going to take this out here because it's that now this is dynamic, this true or false. What would be the best way to take in? Where can I take in this data that I'm bringing in when I instantiate a new class? a new object, sorry. When I call .new, what method gets run?
Is it like initialize? It's been a while since I've done Ruby. So.
Yeah, absolutely. Initialize. So this is kind of like your constructor in JavaScript.
Yeah.
So initialize. If you ever get to the point in your career where you can say, you can type initialize without sounding it out, and congratulations. I'm initializing it with this attribute of ready to adopt. So instead of passing into visit, now I'm actually going to receive that in my initialize. And then how can I store this data so that all of these methods have access to this? Oh, this is ready to adopt. Wait, I don't want this. Ready to adopt should go. Sorry. That isn't here. It's not ready to adopt that we're working with, is it? It is okay to feed. Yes, okay. So this is actually where we're not going to take this. Where else am I calling that? So I'm not calling that anymore with cat time when I do it in visit, and cat time no longer expects that. But I'm still saying feed cats only if it's okay to feed them. So how can I get that working in here?
Would you pass in like
A variable?
Yeah.
Okay. So
instance variable?
All right, beautiful. How do I define an instance variable in Ruby?
The @ sign.
Yeah.
Right.
All right, so let's say, okay, let's just call it the same thing for the sake of ease, although you don't have to. Okay, and then how could I access that down here? Do I have access to it now?
Yes, I think. With the @ sign.
If at okay to fit.
Do I need to put the @ sign?
Yeah.
Let's run it.
Is that a trick question?
Awesome. Yeah, that's working. And hold on, why is that working? I've not called it. Right, it's because of this. Let's get rid of this. So my entry point now is actually visit, right? So let's visit London. We should see that adoption cycle now. We get an error, awesome. So in visit, undefined local variable or method ready to adopt. Right, so, sorry, I did this. Because I'm defining that, my user is going to define that. So I'm going to London and I am ready to adopt, and in London it's okay to feed. So I should see adoption cycle. Actually, I'm not ready to adopt. I should see the feeding, but I shouldn't see the adoption cycle when I visit London when I say false. So let's try that. All right, so may we feed the cats? Yes. And the adoption cycle's gone. All right, so with New York, we'll also say we're not ready to adopt. But with New York, when I initialized New York, I gave it false as my okay to feed. So let's do that. Awesome. So there's no mention of feeding. I didn't see the sign, so I didn't ask. And I also didn't adopt, so that didn't happen. So this would be like the next level of that, taking it to an actual class where we can say, hey, Cat Cafe, do this. And now, if we wanted to, maybe we don't want to visit, maybe we're just on the phone and we want to adopt from London. It's not cool, other stuff. It always gives out after about an hour. Let's just reload the page. Reload. So yeah, hopefully we'll be able to just adopt rather than go through the whole cycle, like of going to the cafe and buying the food, etc., etc. That would be ideal. So hopefully, this is gonna work for us. Dope. Undefined method adopt, adoption. Beautiful. So I was able to just adopt from the London cafe instead of without going through that whole process. So this was really nice. And I didn't have to use any words that I didn't like get, like London, got it. And I could call it London Cat Cafe as well if I wanted to. Cool. So let's well, let me show you my penultimate slide because I think it's cute. It's amazing what bacon can do. That's only funny if you've seen Waitress. So yeah, any questions, thoughts, concerns about what we've spoken about? No, you're all good. Cool. All right, guys. So in the very untrue to form, we finished early. Amazing. So I don't know how fast news travels or if it's got out anywhere yet. But this is my final day with Flat Iron. So that was my last one. So thank you for sharing it with me. I have loved being here, and I think you guys are great. I'm gonna stop recording.
Oh, that's a bummer.